Hi, this is Bob again, November 26, 2011. We're going to do another demonstration. I've done them before, but this is a little different setup. It's going to show two things. For one thing, that a conductor can hold both charges, plus or minus, and at the same time. That's basically, and it's going to show how the conductor can dipole or polarize and hold both charges. And what I've got here in front of me is it's basically an electroscope that I have designed myself. Excuse me here. This is the electroscope part, as you can see, but it only has one moving leaf. The other is stationary. And then you'll see over on this side is a dielectrically covered metal strip that, when this kicks in, becomes a capacitor, and it'll move it along. And I put them in a series. I have a reason for that, and you'll see why. And that's to isolate it from the Wimshurst. Now, remember, this is static electricity in the sense that we're only going to be dealing with potential or voltage. Little to no amperage involved. In fact, I've got the bridge removed from the Wimshurst capacitors so it doesn't build up any, to keep the current to a minimum. We're going to be dealing just as much as possible with voltage in this particular case. Now, these little wire pieces you see from here to the different jar mechanisms are just bridges. It's just copper wire that I've cut to jump from one to the other. Now, this last jar here on the to my left, it's like an oscilloscope, like an electroscope, except it's reversed, and it only has one moving leaf again. But when I apply current, this is going to show you that they have, remember, opposites attract. So what'll happen is, and you'll see it, the leaf will close momentarily until it discharges, and we're just going to show you first the switches have to, I call them switches, they close. As you can see, as long as the switches are closed, now there is no direct, you have remember, each jar here becomes a capacitor. So this is plus, this side be minus, it's minus here, and then goes back to plus again. And if I go too hard, the dielectrics are only good for 600 volts, so I got to keep it pretty low. But you can see that we have two charges and it attracts. You can see that moving. Now what I want to show you, what we're going to do is, normally you would call this a short. In other words, a direct connection between the plus and the minus. If I can get this set up here. I moved it a little bit. It's the trouble when you're working with fixed lengths, but I have to. There we go. There. Now this is just a bridge again. Remember, all these wires here are bridges. That one wants to stick. All right, now we're going to run it again. See if I can, that one leaf wants to stick. There she goes. I think it got some oil on it. It's sticky. But anyhow, we're going to do it again. And you can see that the switch is all closed. If you can see that. I'm just turning the Wimmer ever so slow because I don't need a lot to make this demonstration work. But you'll notice on your left that the leaves do not close. You'll say, well, that's because there's no charge in them because the bridge has shorted it out. Well, that's not true. What it does mean is that there's voltage, a plus on this side. This bridge is in equilibrium and it shows no field and it's equalized, so there's no field charge. So this won't close or open. It won't do anything. It won't move. And if you don't think so, I'm going to show you that there is a charge in that. Now, it's going to take me a second here to convert. And if you hang tight here, I can remove these bridges. There we go. You see everything sort of goes into relaxed mode now, which is good. That's what I want. There it goes. I try to... Okay, I'm going to remove this one. As you can see, just the one leaf moves. All right, I'm going to set that to the side. Now, I'm going to set these are regular electroscopes. There's nothing, you've seen them in my other video. And what I built a special bridge, got a loop in it so it goes over the ball part of the pickup terminal. Set them in close enough. Get them on there. There we go. I'm working around the camera, so I'm a stretching and a reaching, but I'll get there. All right. I think we're still good. Yeah. All right. Now, I'm going to bridge the other electroscope. Remember, I've got two electroscopes here. One hooked to each side. I'll move that in. See if I can get that. There we go. No, I don't have. I'm getting trouble here for some reason. Oh, I see what happened. All right. Nice. This is just wire bridges. It's just regular solid wire. I've removed the insulation where I needed to. All right, now as you can see, we're back. We still have the bridge across here. Now this bridge is what's going to store. You see, it's connected to both minus on that side and plus on this side. And you would think, well, nothing's going to happen. Well, you just take a look. There, you can see by the electroscopes when I give that they're opening up. Now they'll build up so much, and what's happening is it'll discharge through these, because these aren't very strong capacitors at all, so it doesn't take much. But you can see that there's a charge. I don't know if you can see the back one, it's moving too. But these switches are closed, and as I turn it, you can see the leaves moving. And that is how that works. I don't know if I can set it up so we can see both of them or not. It does not appear that's going to happen. Anyhow, I was trying to get it set up so you could see both jaws, but that's not working out that way. But anyhow, it does. So you can see there is voltage in this bridge, and one side is positive and the other side is negative. And that, my friend, is what you call dipole of material. Dipole of matter with electric charge. Now remember, this is all voltage. If I ran a current through here, it'd be a different story. For one thing, my weak capacitors wouldn't hold up very long. But it's arcing now. I can see on the right, this one is arcing over because it builds up enough. It'll break down, and that's why the leaves are jumping. But there you have it. Now, if I remove the bridge, I will charge up, I think, a tight fit. Come on, there we go. Now, that didn't go as good as I wanted, but seldom does. There. Now I've got no bridges. You got plus and minus all the way through, except there. You see? You can keep going until the leaves will actually touch the side of the jar. And they'll stay there until they're dissipated. So you can see that a conductor, even a conductor, and the other dipole experiments I did had to involve paper and some plastic and metal. This one is strictly metal. And I wanted to show you that bridge will hold. I could have left it there. It would take several minutes. Well, it takes quite a while to discharge. When you have a closed system set up like this, it doesn't discharge very rapidly at all. In fact, we're not discharging very fast even now, and I've got the Wimher shorted out, and I still have a very good charge left. I could have. And to show you how easy, I don't know if this is going to work. It might. It might work. I just went there. Now I've actually made another bridge, you see, just by using those two loops. And you know there's voltage there because all the switches are closed. And I've got I got 2 on the negative, 2 on the positive, and they're all closed. And they'll stay there till it dissipates. It'll eventually bleed off and go. But that is what I wanted to show you. It's kind of unique. It's a lot of work to go to for that kind of for that demonstration, but it proves my point. And it shows you what you can do also with these. Are just variants of a electroscope that I made into like a switch, and when it switches over, it turns into basically a capacitor, and that's exactly what you've got. You've got a plate here, you've got your dielectric, and this and the leaf and the reaction is just the other side of the plate. So that's exactly what you have there. Well, okay, I wanted to show you that. I thought that was interesting enough, and you can come up with different ways to demonstrate that if you wish to, but it's a good thing to understand. So we'll talk to you later. Bye.